Hi, I'm Hector Medina, CEO of Monte Caldera Technologies, and I'm glad to present you our startup Canvas, our final project for LBAN's accelerator program at Stanford. After over a decade in management consulting, leading strategy functions at Fortune 500s and advising deep tech ventures, I co-founded Monte Caldera to address a massive bottleneck in materials innovation. So, we define ourselves as the master key platform for advanced materials discovery, or in simple words, we are the Usain Bolt for sustainable materials discovery, and our mission is to help scientists and engineers design new, sustainable materials faster and more accurately, by fundamentally improving how they model reality. Meet Julian, our target user. He's a PhD-trained predictive modeler working in the R&D department of a major chemical company. He's highly analytical, driven by scientific rigor, and motivated by sustainability goals. But today, Julian is limited by outdated simulation tools that don't reflect how materials behave under real-world, non-equilibrium conditions. That means slow development, wasted experiments, and delayed innovation. To solve this, we're building the Caldera Engine, a cloud-based modeling platform that empowers scientists like Julian to discover, optimize, and deploy new materials using Nestlé, an advanced physics theory that models time-dependent, real-world behavior. Think of it as a new layer of modeling fidelity, grounded in rigorous physics, but made usable through a modern SaaS interface. We started designing our prototype using Figma to reflect what we captured on our initial interviews. We wanted a simple yet powerful interface to facilitate users like Julian to explore the platform. With this feedback, we continue to iterate and incorporate features into our MVP, a more mature version of the Caldera Engine, which we have now running on the cloud to further obtain valuable user insights. Monte Caldera accelerates sustainable materials innovation by delivering disruptive physics-based modeling. We empower R&D teams to reduce emissions, cut costs, and bring better materials to market faster. Whether it's paints, batteries, or polymers, our platform helps predict how materials will perform and degrade long before they reach the lab. Our Nestlé-based technology replaces the state-of-the-art in computational physics. The Caldera Engine is the only solution in the materials informatics space incorporating first principles physics and Nestlé advanced algorithms, providing a competitive advantage over the status quo. Precision, speed, and a lower price point than competing solutions due to its efficient CPU usage and data processing architecture. Our go-to-market is built around our scientific edge, Nestlé. We are engaging with research-heavy enterprise partners through pilot programs, publications, and conference demos. We're also targeting university industry partnerships and early adopters in sustainability-focused sectors like chemicals, biotechnology, and energy. We've validated pricing tiers and ARR targets through interviews with materials scientists, R&D managers, and innovation teams, in addition of market research to understand competitors' price points and value propositions. Our pricing reflects the high value we provide, dramatically reduced development time, and lower experimental costs. Each new customer delivers strong gross margins after customer acquisition cost, or CAC, which is estimated at $38,000. This CAC accounts for relevant cost drivers such as sales reps, marketing, and pilots. With high retention potential and a growing addressable market, our average lifetime value is estimated at $200,000. Additionally, our 5x LTV to CAC ratio supports a sustainable and scalable business model in a sector that's long overdue for disruption. With an annualized sales and marketing spend of $190K, we estimate acquiring 5 customers in year 1, resulting in a CAC of $38K. This is aligned with benchmarks for enterprise deep tech SaaS, where CAC typically range from $30K to $60K. Our assumptions include a 6-month sales cycle, 10 to 12 pilots annually, and a 40 to 50% conversion rate. Given the high LTV of each enterprise customer, we expect strong margin contribution post-acquisition, supporting a scalable and sustainable growth model. Our business model is based primarily on a SaaS component, which assumes 80% gross margins and a 5% royalty sharing. For our calculations, we assume a conservative 5-year lifetime. Applications of our Nestle-based technology are broad across multiple industries, and we are focusing on the ones we know can deliver the highest impact. From safer ingredients to sustainable materials and affordable therapeutics. Ultimately, we will be making 95% of the things that you see around you every day in a better, safer, and faster way. With our pre-seed investment, we validated key hypotheses, developed our initial prototype and MVP, and refined both our business model and go-to-market strategy. Our next phase is focused on scaling our technology and building market traction. To support this growth, we are raising a $5 million seed round. To wrap up, we're not just building a better modeling tool, we're redefining how the world discovers materials. If we're successful, we'll accelerate the pace of sustainable innovation, help decarbonize major industries, and unlock a new era of scientific creativity. We are a team of 14 PhDs in applied physics, nanotechnology, material science, and chemical engineering, all co-authors of the Nestlé Advanced Physics Theory. If you want to transform the world through science, we want to hear from you. Visit us at montecaldera.com or scan the QR code now. We're Monte Caldera Technologies, and we're engineering the future, one equation at a time. And finally, I just want to say thanks to all the LBAN team for this amazing journey. It was an incredible experience and a privilege to getting to know you all. See you soon.